Morning, sir.
Good morning. How are you guys?
Yes,
Good,
sir.
how are you?
I'm good. Thank you. Can you hear me clearly?
Yes, sir.
Yes, sir.
Okay. Okay, guys. Okay. So you are taking your test tomorrow, right?
Yes, sir. Yes, sir.
Good. Guys, just to let you know this thing that this time I have not prepared the answer key for the practice test assignment. But some of the examples, almost I would say more than 50% of the examples are solved in the note in our classwork, in our class notes, whatever I have posted on Canvas. And other examples, they are just similar. So most likely, or I'm pretty sure that for 50% of the example, you won't be having any problem. Rest of the examples, you can just work accordingly, try to, if you want, I can do one thing for you. If you want, you can submit those homework assignment to me by today on Canvas. And if I find something wrong, I will let you know. So that's another way to figure it out. You can submit everything to me on Canvas by today around 8 p.m. And I will try to grade your exams, I'm going to say your homework, right? So that you can't repeat the same mistake in the exam. That's the one way, that's what I can do for you. And I'm not sure for the second test, but yeah, I will plan, because third test, there is chapter 4 and that is very important. Lots of big answers are there. And that's why I will try my best. I can't promise you, but I will try my best to give you the answer key for the third test, right? So probably that will be helpful to you for third test and probably the last test too, but I don't know. But at least for this time, yeah, I can do this thing. You can submit your homework on Canvas and I will grade it. So yeah, that is one thing. Second thing is, do you want me to share my videos with you guys? Whatever we are discussing over here, I can submit the same thing. And I can share my videos with you guys. You want it?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay, so let's do one thing. Yeah. I can, what? I can put all these videos on YouTube. Okay. So that you can see whenever you want it. In your free time, you can just listen to the things, you can just watch things, and you can get lots of things. But only thing is, I request you, yeah, please subscribe me. Okay. Okay, so yeah, I will do that thing for you. I will try to submit all my videos on YouTube, and probably that will be helpful to you. Okay, guys, so now let me share my screen with you for, where is it? Class notes, not this one. 311, right? Yes, 311 and class notes, and we are on chapter 1. Okay, so now let's share my video, share my class notes. Before I share my class notes, I want you guys to just pick your names.
Elias Tyson.
Okay. Elias Tyson. Next.
Alex Cirillo.
Zach. Next.
Solomon Harris.
Solomon Harris. Next. Solomon Harris. Then next.
Nick Campbell.
Nick Campbell. Next.
Ishmael Taylor.
One by one, please. Yes, Nick Campbell. Then who is the next?
Ishmael Taylor.
ISH is. So you are in my both classes?
Yep.
Okay. Good. Yeah, he's a brave guy. See, hey, what's your full name?
Ishmael Taylor.
Ismail.
Yes, M-A-E-L.
Oh, M-A-E-L. Okay, Ismail Taylor. Okay. Yeah, he's taking Calc 2 and DFQ both simultaneously. See, brave guy. Good. Next.
Margie Vyas.
Marky Vyas. Next.
Paul Mushton.
Paul Mustaine. Okay, next.
Nina Rodriguez.
Lena, I can't see you.
Can you see me now?
No,
No? I have my camera on.
now I can see you. Yeah, you're good. You're good.
Okay.
Okay, and I think that's it, right?
Gage Levine.
Oh, okay. Gage Levine. Okay. Ismail Taylor. Yes, now I can read your name.
Yeah, I changed it.
Yeah, it's a ISH. And I was just wondering what does it mean, ISH. Now that makes sense to me. Good, thank you. You changed over here, so yeah, of course I can see the same thing in more Calc 2 also, right? Good.
Mhm.
Okay, guys, so let me share my video with you. Not video, my class notes with you. And yeah, look at over here. Example 1 to 8. Already I solved. This example, y equal to negative of cosine x ln of. It is there in the solution, classwork. E to the mx. We solved this one yesterday. C, you can verify yourself, very easy. The easiest one out of these 4. Example number D, already there in the notes. Example number 3, I solved this one yesterday, if you remember, just for this part. Similar for, you can just repeat the same thing for B, C, and D. You can't expect 100% from me. Then example number 4, I solved this one for first example, initial conditions. This one and this one, second order differential equation, 2 initial conditions. Exactly, you can same way, just repeat the same thing for different values. You are just changing the numbers, nothing else. Okay, then after example number 5, I solved this one, but we discussed this, and this. So example 5 is done. Example number 6, I solved the first one. Exactly same way, just repeat the same thing. Part 2, I solved the first one. I think we did both the things, right? Yeah, first one we discussed over here, and second one is there in the class notes. So you are having the solution of this one too. Everything is there. I don't know. Margie was asking me this thing, right? Okay. And separable variable, we have not started so far. So up to example 6, I think almost you guys are having 90% of the practice test solution. Am I right, Margie?
Yeah.
Right. I saw your email, but I thought that what
Yeah, I mean,
we discussed
so
this
like,
thing.
it's just good to know if I did it right or wrong, but yeah, that makes sense.
But again, Gargi, if it's just similar things, it's a matter of numbers, right? If it is different, some different methods are there, something different, definitely, I'm not going to skip that thing.
Mm-hmm.
I'm going to take all different kind of examples over here. So you will, and that is my job. I will make sure that you guys will not face any problem. And if you are facing some problem in somewhere, suppose you are stuck at some point, just let me know over here. Immediately you will get the answer. I trust you. Please trust me. I promise you. Okay. And again, it's lots of work. Throughout the day, you won't believe I start my day every morning at 5:30. Yes, 5:30, I just get up early in the morning. 6:30 to 7:30, that is my meditation time. 7:30 to 12, almost quarter to 12, that is my teaching time. My lunch, again, my research time, 12 to 4. Yeah, and then after again, I'm working with this to install the videos and all these things, some kind of work. 6 to 7, I go for a walk. So that is my schedule. So it is a summer, but even though I'm too busy. Yes, and the night, 8 o'clock, after 8 o'clock, I don't do anything. I'm getting tired. I don't do anything after 8. I just watch TV for news, BBC News, CNBC News for an hour or like this. Then I go to bed at 10:30. That's my schedule. But of course, I don't say it's an excuse. I don't want to give you any excuse, but I will try my best to give you the answer keys for your third exam. Your second exam will be just probably more than easier than this one, because second exam I'm going to provide a packet and I'm going to ask you only from the packet. So it will be way easier than the first exam. First exam is easy, of course, but the second one is easier than the first one. And third one, of course, you need guidance. You need some help. I know. And that's why I promise you, I'm going to give you all the things answer keys. Anyway, guys, so separable variable, that's what we have started yesterday. We solved first example, am I right? dy by dx is y square minus 4. That example, that's with you. Then after I solve number D, sine 3x 2y cosine cube dy equal to 0. Am I right? Margi, am I right?
Mm-hmm.
Yeah, so we solved A, we solved B. B is again easy, to the power 2y minus y cosine x dy dx. So I can send this x part on the other side. So I can divide by e to the power y throughout and cosine x. So divide e to the power y and cosine x. If you want the hint, write it down. Divide throughout by e to the power y and cosine x. So if you divide over e to the power y, it is e to the power y minus y e to the power negative y. Here, for y e to the power negative y, you have to use the integration by parts. First integration is easy. Here, y e to the power negative y, use integration by parts and dy. That is equal to sine 2x divided by cosine x. Sine 2x divided by cosine x. Use the formula for sine 2x. Sine 2x is 2 sine x cosine x. Formula said page number 2, middle part. Just below the unit circle. Sine 2x equal to 2 sine x cosine x. So cosine x and cosine x from numerator and denominator will get cancelled out, and you are getting simply 2 sine x, and integration of sine x is negative cosine x. Am I right? Am I right?
Yes, sir.
Thing you
Right.
guys, you are
Yes, sir.
taking your exam tomorrow. This is just, you can consider as a part of your review, right? And here you have initial condition. So once you get the answer, then after replace your x by 0. So y at x equal to 0. So just plug the value over here and get the value of the constant c. Go back and plug it back, the value of c. And that is the end of the example. Next, dy by dx is x plus 1 whole square. The easiest one. Send this x to other side. Separable variable dy equal to x plus 1 whole square and dx. Right? X plus 1 whole square is x square plus 2x plus 1. Term by term integration, you are done. Just term by term integration, you are done. This one is done. If you want, I can solve this example for you, because I know you may face little difficulty over here. I can solve this example E for you.
Yeah, can we go over that?
Yes. So I solved A, I solved D. We discussed this and this. E I'm going to solve over here. Dy by dx equal to x 1 minus y square. Take divide by 1 minus y square throughout. So 1 over square root of 1 minus y square dy equal to x times dx. Right? And then get the answer. Integration both the sides. Okay, guys. So that's how you can solve these examples. Let me start with this example number E. How I solve example E, just pay attention. Let me work for you. It says that question number what? 7 and which part? E. E to the power x. You guys can write it down with me. E to the power x y dy dx equal to e to the power negative y plus e to the power negative x minus y. Agree? Can you see the last portion? The last portion I would like to write e to the power negative 2x minus y as e to the power negative 2x times e to the power negative y. Shall I write like this? or I will take the picture of this one and will send to Nina so that she can forward this page to all of you. You want it?
Yes, sir.
Yes.
Okay, no problem. Why I did this thing? Because if I do this thing, I can get e to the power negative y common. Am I right? See, just guys, please look at me. See, whenever you solve in mathematics particularly, whenever you solve the example at that time, suppose you are writing the second step. In the back of your mind, third step must be there. It would be way easier for you to write down your second step if something is going on in your mind, if you are thinking a little bit about your third step. That is the way of doing mathematics. I have been practicing this thing since last 25 years. Yes. Before, probably. Right, guys? So that's the way of doing mathematics, not mathematics, all the subjects. Okay, so if I do like this, so that is equal to e to the power negative y and 1 plus e to the power negative x. And my left hand side e to the power xy is equal to dy, and now I can write dx. Shall I write like this? Shall I write like this? Say something. Oh my.
All right.
I need your response.
Got it, sir.
Guys. Good. So now, what is the next step, guys? I need your help. Guide me. Margie, guide me. No. Ismail Taylor.
I don't know.
Hey, don't disappoint me.
Would you want to take the natural log?
No. Since your variables are not separated, you are working with separation variables. Your variables are not separated so far. Yes, Ilyas Tyson, my friend, go ahead.
I'm looking at it, sir, but I'm confused as well. I hate.
You are confused. That's good. Alex.
You have to get the e to the negative y to the other side.
Very good. Okay. E to the power negative y to other side. That means throughout we are going to divide by e to the power negative y. That's it.
And then
Anything else? Yes, Solomon, you are on the right track. Go ahead.
take the e to the x to the other
Let's
side.
do. Say again.
Take the e to the power of x to the other side.
E to the power x to the other side means you are dividing throughout by e to the power x and e to the power negative y. Agree?
All right.
Yes.
Yes, sir.
Are you guys okay now? See, Solomon Harris, he guided you. Thank you, Harris. Okay, so let me divide throughout by e to the power x and e to the power negative y to separate my variables, e to the power negative y. So e to the power this, and this will get cancelled out. Agree? Please say yes.
Yes, sir.
Thank you. Don't keep quiet when I ask you something. Okay, so this implies that y e to the power y dy equal to 1 plus e to the power negative 2x and dx. Can you see I separated my variables?
Yes, sir.
Yes, sir.
Thank you. Good. Now go for integration. Shall I say like this? See, this is the way of writing. Look at over here. The way I'm writing this equation. See, I separated my variable. I wrote it down in the brackets, separate variable. I took the integration. I wrote down plus c. Look at here. See, when you write the exam at that time, consider that your teacher doesn't know anything. He is just a dumb guy. He doesn't know anything. Yes. And write down everything. Explain to him everything. That way, you are creating what? Means you're not leaving any room to cut your points. Right? So try to explain everything, that just considering in mind that other guy, he doesn't know anything, and you are explaining to him everything. Okay.
Okay.
Now again, Nina. How can I get the integration of first part, left side?
Integrate to the first side. Would you can pull the y, e to the y out?
Are you crazy?
No.
How
Wait.
can you put variable outside the integral sign? You can only play with the constant, not with the variable. As I told you this thing in Calc 1 too. Nina, that's not fair.
Yes, sir.
Try it.
Wouldn't you integrate it by part?
Correct. You got it. Integration by parts is the product of two functions, right?
Yes, sir.
You got it. See, I knew that.
Where did the e to the x go from the top part?
If
On
the
the-
x is not there.
The denominator?
Oh, where is it?
The e to the x from the
It
denominator?
is there. It is there.
Oh, okay.
It
Just
is
confused.
there. But right now, Nina is right because I asked her only left side and she said integration by parts. She is right. Let me encourage her. Queen Heart, are you okay?
Yes, sir.
Good. Okay, so now, Queen Heart. She says integration by parts. Go ahead. Oof. Integration by parts. Go ahead, guys.
Is it
Parts.
do you want me to explain it all
I
the
told
way
you
out or what
every
I
class
got?
I am using Calc 2. I told you, please. Go ahead.
So what I came to is y e to the y minus e to the y.
Y e to the y minus then
Minus e to the y.
e to the y. Is it right?
Wouldn't it be minus the integral of e to the y?
Integral e to the y is e to the y. He is right. Of course you are right. Integral e to the y, but integral e to the y is e to the y. Right?
Yes, sir.
Right.
Okay. Margie, are you following these two guys?
Yeah, I think it's just been a while since I've taken calcs, so I don't remember all the rules. off
When
the
did you
top
take
of
your
my head.
Calc 2?
I took it second semester freshman year, and I'm a junior now. Or I just
Right.
junior, so it's been like 2 years.
Oh. Why? It's a big gap.
What?
It's a big gap between Calc 2 and DFQ.
Well, at NC State, they make you take Calc 3 and then DFQ.
That's always the problem.
Yeah, so
Always. I'm sorry, but that's, usually, if you are STEM major, your science or engineering discipline, your advisor always advises you to go for Calc 1, 2, and then 3. But that's not the right sequence. Guys, at VMI, I have really good friends in almost all engineering departments, and we have been discussing this thing so many times. I just got upset. Yeah, I told them, don't do this thing, please. Let them allow to go for DFQ before Calc 3, immediately after Calc 2. And they just listen to me. Yeah, at that time, they are really very serious. But after that, they just forget. So many times, I talk to everyone. Yeah, you won't believe me, but yes, I talk to everyone, almost. Civil engineering, mechanical engineering, electrics, everyone. But even though the same thing I'm facing every time. Not your fault. I do agree with you. Not your fault. Fault of your advisor. Sorry. But yes. Sorry, I don't want to blame anybody else. But let me continue with my example. So, Margie, it's an integration by parts. So, let me write for you the formula because I'm pretty sure you forgot the formula. Am I right?
yeah, I think if I see the formula, I'll know. I just don't remember the formula. So off the top of my head, I can't.
Top
I
of
don't
your
know.
head. That's good. So integration u into v, that is equal to u as it is an integration of v minus derivative of u and integration of v. This is the formula. Our second formula is usually people write like this. U and dv, that is the same thing. So it is uv minus u dash of v. So usually I use the first formula. I wrote it down two formula over here, mainly for Margi because, or those who have a gap between Calc 2 and DPQ. Yeah, I usually use first one, but second one, both are same actually. This is yours. So y e to the power y minus derivative of y is 1. E to the power integration is e to the power y. So Lx is absolutely right. My left hand side is, sorry, right hand side is e to the power negative x plus e to the power negative 3x. Agree? Shall I write my right hand side like this? Oh my gosh, say something, my dear friends.
Yes, sir.
Solomon Harris is good. Campbell, are you okay? Nick?
Yeah, I think that's a better way to do it, sir.
Yes, sir.
And Gage,
Yes, sir.
Gage Levine.
Yes, sir.
Gage, yeah, if I don't speak your name, that doesn't mean that I'm not taking care of you, okay? So please, please. If I don't speak your name, anybody's name, that doesn't mean that I am taking care of all of you, please. Okay, Will Hostler, are you okay? Will, I can't see you.
Yeah, I'm back, and I'm still on my phone again, so I figured y'all wouldn't just want to be staring at a ceiling.
Okay, so still you have not fixed your problem, right?
Well, I tried to take my laptop to somewhere, and they said it'd be $1,000 to fix it because there's a
No, $1,000. Oh my gosh.
Yeah,
You-
yeah, and that's the
Laptop,
price.
HP laptop in $600.
Well, no, that's just what they said. Just
Yeah, I believe you, but it's crazy.
and then my job down in Raleigh is giving me a laptop for work, so I figured why would I get a laptop just for like a month?
Okay,
So
okay, good.
I'm improvising.
But you are following me, right? You are getting me, right?
Yeah, I just got in because I was using the Zoom ID that you
Oh,
originally gave us in that email because that's what I've been using the past few days, and I don't know what was up with it. So I was just sitting here.
yeah, first day what happened, I set up the Zoom meeting with that ID, and then after my computer was not working, it was just disconnected from the Wi-Fi very frequently, and you guys were facing some problem, even I was facing some problem, so that's why I changed my computer. I changed my laptop. That laptop is that's the VMI laptop. It's not working.
Yeah.
Yeah, and I put the complaint. I mean to say, I contacted the help desk, and she said they don't have any more laptop. I said fine, okay, let me use my laptop. So see, mine is working well, so something is wrong with that laptop. So yeah, that sometimes it may happen. Yeah. Anyway,
Same problem.
I had to arrange the another meetings, and that's why my password and everything is changed. But I sent the email to you. Second email was there. Am I right? Anyway, let's continue with this one. So that is equal to integration e to the power negative x is negative e to the power negative x, and okay, Nina, what is not Nina? No. Nick, what is the integration of e to the power negative 3x?
I'm gonna take a wild stab at it, sir. That it's -3 e to the negative 3x.
I am asking you integration, not derivative. You are giving me derivative right now. Am I right? Am I right?
Yes, sir, you are. I'm sorry, I didn't get much since last night.
So what is the integration now?
I'm gonna need a second, sir.
Okay, not second. I can give 60 seconds. Okay, 1 minute. Go ahead.
All right. I'm just trying to think this out really quickly.
Yep.
So which problem are we going over right now?
Question number 7E.
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 All right.
Sir, I'm completely blanking right now. I'm sorry.
Okay, Solomon Harris. Help him.
I'm trying to figure it out too.
Oh my God. Nina. Yes, e to the power negative 3x integration.
E to the power negative x.
Negative 3x, e to the power negative 3x integration.
Wouldn't it be negative e to the x? Oh wait, negative e to the negative x.
I think I got it, sir.
The second part, e to the power negative 3x. Ismail Taylor.
Would it be negative 3x times e to the negative 3x?
Negative 3x times? What are you speaking? No. Nick gave us the derivative. You are also taking that. I'm asking you integration.
Is it an integration by u substitution, sir?
Yeah, you can use u sub u equal to negative 3x. I don't mind.
No.
But you have to have small technique, because every time if you are using for such small type of things, if you are using u sub, you are extending the length of your example and you're using your time also. So that's not a good choice. But anyway, yeah. Then to whom I should ask? Elias Tyson?
I've got negative 1/3 and then e to the negative 3 times e to the negative 3x.
Margie? Is he right?
Well, it wouldn't be times, it'd be to the power.
He said e to the power negative 3x divided by negative 3. That's what Elias says.
Yes, that's what I got.
Is he right? Margie, I'm asking you. Just set up your video properly, please. Okay. What do you say? Any comment?
She's muted.
She is mute. Oh my gosh.
Oh, I didn't know it was
My
muted.
gosh. My gosh, I've been waiting since last 5 minutes for you.
I don't think he's right.
He is not right?
Yeah, I did the u for e to the 2x.
Okay.
I did u substitution.
Okay,
but I
Paul
never said
Mustaine. Is Elias right?
Yes, sir, he is right.
Okay.
Yeah, that's right.
Ismail, is he right?
Yeah.
Okay, Alex?
Yes, he's right.
He is right. Thank you. See, integration and derivative, they are the reverse process of each other. In derivative, e to the power negative 3x, you are multiplying by negative 3. Negative 3 to the power negative 3x. In integration, you divide by that number. Simple. So it is e to the power negative 3x divided by negative 3 plus c. Right? Otherwise, as somebody says that, yeah, you can go for u sub u equal to the power negative 3x. Just solve it in separate piece of paper and write down the answer. So right now you are over here. See, we are just, I can't spare half an hour just for one example like these guys. Agree?
Yes, sir.
Yes, sir.
Because, okay. So this implies that y e to the power y minus 1 equal to negative e to the power negative x, negative 1/3 e to the power negative 3x plus c, negative 3x plus c, that is your answer. That is your answer. You don't have to do anything else. Look at here. In this problem, the initial condition is not given, but suppose I give you some random initial condition. Suppose y at 1 equal to 2. Suppose I give you y at 1 equal to 2. So let me use this condition since y at 1 equal to 2. So let me replace my x by 1. So negative e to the power negative 1, negative 1/3 e to the power negative 3 plus c, and y at 1 equal to 2. So e to the power y at 1, that is equal to 2. And here it is 2 minus 1. So e to the power 2 is equal to negative 1 over e minus negative 3 to the power 3 plus c. So c equal to e square plus 1 over e plus 1 over 3 e to the power 3. Look at here. If I give you some initial condition like this, so apply the initial condition, you are going to get this type of things. And then use your calculator, you're going to get one answer. So use calculator, and whatever value of c you're getting, just go back and plug that value in your c. What is the value you are getting? Just go back and plug your value in your c, in your answer. Agreed?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, I will take the picture of this one and I will send it to you. So this one is done, and now we are going to start the linear differential equation. Linear differential equation. Honestly, please tell me, how many of you are working with me? Means daily base. Daily, how many of you are spending 1.5, 2 hours, 3 hours for this subject? Be honest.
I am.
I am.
Very nice. Nick,
I'm spending about 2 hours a day, sir.
very nice. Ilyas,
Yes, sir.
Margie,
Yeah.
how many times?
I
How
spent
much?
about 3 or 4 hours yesterday.
Oh, Will?
Yes, sir.
Oh, wow, that's nice. 3 to
Well, I'm basically having to reteach myself Calc 2. So that's not real fun.
Yeah. Yeah. You can do one thing, Will. Where are you right now?
Just in Richmond.
In Richmond. Okay. So what are you doing at 7:30 to 9:30 in the morning?
Sleeping.
Sleeping. Good. Okay, guys, if you are free in the morning at 7:30 to 9:30, and if you want to join my Calc 2 course, Margie, if you want to join my Calc 2 course, I will allow you. I will allow you. Okay, just join if you want. And I am going to start the new chapter that is called Techniques of Integration from tomorrow. Yes, tomorrow. And this is the only chapter we are using a lot over here. So if you want, you can join me tomorrow. Okay, not just tomorrow, but at least for the whole week. It's just 1 week, but you will be getting lots of ideas about the integration. And that will make your life very easy for DFQ.
I don't know if
All right. Thank you, sir.
I give you this opportunity, but I would like to provide you this opportunity. You can join my class of Calc 2. And fortunately, I'm teaching Calc 2 this time. So you will take this advantage. Join that class, and probably after a week, you will be absolutely good if you are really willing to know something. If you are really willing to learn something. Okay. So all you guys are invited. Only thing is you can't disturb our other guys. I have to give the first priority to other guys, my original students. But if you have some doubt, we can discuss your doubt over here in our section. Okay? Or you can ask me over there too, I don't mind. But if it is very small question. Sounds good?
Yes,
Yes,
sir.
sir.
Will, if it is possible, don't sleep in the morning. Get up early in the morning and join us.
I might just have to do that. I don't know if I would do tomorrow though, since that's right before.
Tomorrow is the beginning of that chapter. So if you want, don't skip that part. Otherwise, in the middle of the chapter, probably you will be losing something. You will not be
Well, with
getting.
that being right before the exam, I don't want to burn myself out trying to.
Oh yeah, that is right before the exam. But let's do one thing, guys. I can teach only for half an hour or like this, 7:30 to 8 or like this, or 8:15, and then after I will stop. I will just try to review other things for them, just because of you guys. So if you want, you can join me for first 50 minutes or like this, and then after you can continue with your exam, with the preparation. You can leave the meeting. And
All right.
if you don't want it, it's your choice. It's your choice. It's not mandatory. It's your choice. But you are rarely, you will have rarely given this type of opportunity. It's your choice. If you want to take this advantage, that's fine. Otherwise, it's your choice. I don't want to say anything. Anyway, good. So now let's start the linear differential equation. Linear differential equation, Nina, give me the definition of linear equation. We did linear equation on first day on the classification of differential equation, order, degree, and linearity. What's the definition? Quickly.
Of linearity,
Mhm.
I have the dependent variable equals y, and the
Mhm.
power has to be just 1.
Power. Okay.
And the function must be function of x, which is independent. And so it's everything raised to the first power.
Everything means y, dependent variable y, and all its derivative must be of first degree, means power 1.
Yes,
and
sir.
they are not multiplied together, right? This,
Yes, sir.
so please be specific. Okay, these two conditions are there. And then after, if you remember, I gave you the general form of the differential equation. I think now let me start with the work because I don't want to. Okay. General form of the differential equation. And that general form of that linear differential equation is dy by dx plus py equal to q, where p and q are functions of x or constant, right? The solution of this type of equation is given in this form. First of all, you need to find the integrating factor. Integrating factor is given by e to the power px dx. E to the power px dx. And the general solution is y times, y means dependent variable. Dependent variable times integrating factor, whatever you found here, is equal to right hand side integration, qx is your right hand side, times integrating factor dx plus c. You have to memorize this thing, this solution. You have to. It's not there in the formula sheet. You have to memorize this. So this is the general equation for the general form of the linear differential equation, and this one is the solution of the linear differential equation. First of all, you need to find the integrating factor e to the power px dx. Px dx, p is a function of x. Look at over here, because it's an independent variable. X is the independent variable. If your equation is in the reverse form, suppose dx by dy means x is dependent and y is independent. In that case, here you are going to get dx by dy equal to px, here it is x, equal to q, where p and q are the functions of y. P and q always are the functions of independent variable, whether it is x, y, what it may be, always the function of independent variable. Look at my cursor, please. Right? Good. Good. So here it is y dependent variable integrating factor equal to integration q right hand side integrating factor dx plus c. If it is dx by dy, in that case, your integrating factor will be e to the power p y dy, because p is a function of y now, independent variable, y dy. And here it is x integrating factor equal to integration qy integrating factor plus c, if it is dx by dy. So depending on the nature of the differential equation, Alex, here please. Yes. Now let me take one simple example. Dx by dy minus 3y equal to 0. Compare this equation with the standard form. So dy by dx, p is negative 3. See, plus has to be there. Plus means p is negative 3. P is negative 3. Y as it is equal to 0. P and q must be 0, some constant, otherwise function of independent variable. So dy plus, see, p, this one I wrote it down very separately so that you can figure it out each and every step, each and everything. Once this is the standard form, then after I can go for the integrating factor. Integrating factor is e to the power px dx. P is negative 3, so negative 3x dx. Negative 3 is constant, just pull it out. Integration of 1 is x, so it is negative e to the power negative 3x. Then use this formula, general solution y, dependent variable, multiplied by integrating factor is e to the power negative 3x equal to integral q is 0, so 0, integrating factor e to the power negative 3x dx plus c. Because it is 0, this will vanish. So y e to the power negative 3x equal to c. Divide throughout by e to the power negative 3x. So y equal to c times e to the power 3x is the solution. Y equal to c times e to the power 3x is the solution. Y is equal to c e to the power 3x is the solution of given differential equation. Just now, as we discussed, if you have a reverse form, part 2, reverse form, x is the dependent and y is independent. So it is px and q. P and q are functions of y, always independent variable, otherwise constant. excuse me. So general solution will be given, sorry, integrating factor will be e to the power p dy. General solution is dependent variable x. Integrating factor equal to sine of integration qy, integrating factor dy plus c. After this class, immediately I'm going to post this video on YouTube. So please, if you want, just go through it. Okay. My next example. You are not going to get always the standard formation of linear or non-linear differential equation. Sometimes the equations are given in some random form. You have to set up that equation in the standard form. Right now, I'm giving you like this, the separable variable, linear, separately, so that you know that this example can be solved by linear method. But in the exam, you will be provided a bunch of examples. One is separable variable, one is linear, one is non-linear, one is homogeneous. You are the right person to figure it out which method is to be applied, is to be implemented for the given particular example. And there is no particular method for that. Only practice will make you perfect. You have to practice number of examples. Yeah, solve 15, 20 examples each based on each method. Only then you will be confident also of solving the examples. Don't try to memorize the things. Yep. One more thing. One differential equation can be solved by several ways. Suppose I give you one differential equation. It may possible, not always, it may possible that that differential equation can be solved by separable variable, by linear, by homogeneous, by non-linear, something like that. Some equations are there which can be solved by homogeneous way as well as the non-linear method, both ways. Yep, I will give you the example when time will come. So if nothing is mentioned, you are free to choose your method. Only thing is you have to go through on the right path with right method and right answer to claim your full points. Right? So please make sure this thing. Right now, again, let me remind you, we are working with first order, first degree differential equation, different methods. Example number 8A. I have not taken 1, 2, 3. Why question 8? Because that is practice test. Practice test question 8A. I told you yesterday that always keep your practice test in front of you. This is the example given to you. Am I right? I took first example. That was just a random example from the book. Second example based on practice test from your exercise problem of the book. X dy dx minus 4y equal to x to the power 6 e to the power x. This is not in the standard form. I want to convert this one in the standard form. What I'm going to do, divide throughout by x, so that my dy by dx will be separated. Because my formation says that dy by dx plus py equal to q. Coefficient of dy by dx is just 1. So let me do this thing. Let me divide by x. If I divide by x throughout, -4 divided by x. I keep my y separately. Why? I will let you know. If you divide by x to the power 5 e to the power x. This is a function of x now. So it is my q. This is my p is a function of x only. So that's why I took my x only below -4, separated from y, because I wanted to make sure that this expression is following my formation. So dy by dx as it is, -4 over x is my p, as of p is a function of x, y separately, y is a function, dependent variable, q is a function of x. So this is the standard formation, linear standard formation now. I am allowed to go for the integrating factor only after setting up the formation. Once you have this format, then after you can go for the integrating factor. Integrating factor, my e to the power p dx, p is -4 over x. -4 is constant, pull it out. Integration of 1 over x is margi ln x. Agree? Oh my gosh. Integration of 1 over x is ln x, right? Can you hear me, guys?
Yes, sir.
Yes, sir. That's right.
Yes, sir.
Okay. So Don't mute your voice, please.
Sorry, my parents are like talking in the background downstairs, so I didn't want it to interfere with class.
Okay. But you can close your door.
I mean, yeah, my door is closed, but I didn't know if you could still hear anything, so I just didn't want to get in the way, but I can unmute it.
That's fine. E to the power -4 and ln 1 over x is ln of x. Now guys, look at here. You have to convert this one in the standard form, I mean to say in more simplified form. You have to. Otherwise, you cannot proceed further. Yeah, this is x, which you cannot find in the book. In the book, you can get the answer, but nobody is going to let you know this thing that why we want this one. So many times I told you that exponential function and logarithmic function, they are the reverse of each other. Am I right? Here
Yes,
I
sir.
power -4 ln x. This to the power -4 ln x. Am I right?
Yes, sir.
I can write this one as e to the power ln x to the power -4. Why? Because ln of a to the power b is b times ln of a. This is one of the properties of logarithmic function. One of the properties of logarithmic function. Ln of a to the power b is b times ln of a. You are given this right side, b times ln of a. B times, just compare over here. And I want to write this right side as a left side. Look at over here. Why? I will let you know. So that's what I did over here. My b is -4, b is -4, ln x is a. And that's why I can write e to the power ln of x to the power -4, ln of a to the power b. Agree?
Yes, sir.
Yes, sir.
Right? Now e and exponential function, they are the inverse of each other. That means you can cancel this one. You can cancel this one. And you are getting simply x to the power -4. So simply that is equal to x to the power -4 or 1 over x to the power 4. That is the reason that you have to simplify this thing. Are you getting me, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Once you get this simplified form, that is your integrating factor, your general solution is y is the dependent variable. Integrating factor, you figure it out 1 over x to the power 4. Right hand side is already this one, x to the power 5 e to the power x, and my integrating factor is dx plus c. So I'm getting this expression. Agree?
Makes sense.
Yes, sir.
Ilyas, Ismail, Nick,
Yeah, got it.
Yes, sir.
Good. Okay. So I can cancel this one and this power 5. Nina,
Yes, sir.
good. Then Mustain, Paul Mustain, Solomon Harris, Gage Levine. Good. Okay. Good. So now your integration will be integration x e to the power x dx plus c. Again, you have to use the what? Integration by parts. X e to the power x. And that's what I have done over here. Look at here. E to the power x u into v by parts. So x e to the power x minus derivative of first term, integration of second term. So you are getting this term. Multiply throughout by x to the power 4. If you multiply throughout by x to the power 4, you are getting this one. That is your answer. Either this one or this. I don't bother. Any one of these is the answer. Agree?
Yes, sir.
Yes, sir.
Good. So that's what we mean by the linear differential equation. Easy? Easy?
Yes, sir.
Yes, sir.
Kind of.
Good. I like it, Elias. Good. Let's go for one more. Example number 8C. Practice test. I don't know why, but I like this example. I don't know why. It's just like other examples, but I like it. I always say my students when I'm in class that try to pick up my words. Yeah, so many times throughout the course, I am providing lots of hints to my students. Which type of examples? Some people are asking me which type of examples will be there in the exam.
Yes,
If I
sir.
say I like this example, if I say this is really important, awesome, nice example, at that time I think you need to blah blah blah. You know it what I mean. Thank you. So y dx. Now look at here, guys. This why I took this example. Y dx minus 4x plus y to the power 6 dy equal to 0. You can write dy dx. You can write dy dx. Don't look at on left side. Just look at my cursor. Suppose I think that I can arrange this one in the form of dy dx. So I can write like this, dy dx equal to, let me send this to other side. So y divided by 4x plus y over to the power 6. Agree? Is there any way that I can convert this one in the standard form dy by dx plus py equal to q? No, I cannot. Because big expression is there in denominator. If it is there in numerator, I had some chance or chances to arrange this one in the standard form. But here, big expression there is denominator, so it doesn't allow me to arrange this one in the standard form of dy dx plus py equal to q. So let's just cancel this part and let's try the other way around. Other way around means let me take dx dy. See here, I send this one to other side, dx by dy, and I divide it by y. If I divide by y, 4x plus 4y to the power 6 by y. Let me separate 4x by y and 4y to the power 5. See, I'm getting something. Dx dy equal to, let me send this to other side. So negative 4 over yx plus 4y to the power. Don't you think this is second type? Dx dy, x is dependent, y is independent. So dx dy plus px equal to q, where p and q both are functions of y. That's why I put a big circle. Second type example. So my integrating factor, standard formation, integrating factor will be e to the power p dy. P dy. Take negative 4 out, 1 over y dy, ln y. Again the same technique, guys. Take this negative 4 as a power of y using logarithmic property. E to the power y to the power negative 4, y to the power negative 4, 1 over y to the power 4. So you can't work with this one as your integrating factor. You have to have the simplified form 1 over y to the power 4. Make sense, Ilyas? I think so.
Yes, sir.
Good.
Makes sense.
And now my dependent variable here in this form is x multiplied by integrating factor y to the power equal to integration q. Q is 4y to the power 4. Integrating factor is 1 over y to the power 4 dy plus c. Cancel the common things. Just 4y is left out. So 4 integration y square by 2 and c. Right? 2y square plus multiply throughout by y to the power 4. Here x is a function of y. Previously y was a function of x, but here we are working with the reverse case, second type. So x is a function of y, 2y to the power 6 plus 4y to the power 4. But that's not done. This is not the solution. I cancel this one. Look at here. Because you are given initial condition, x at 1 equal to 2. If x at 1 equal to 2, means when you replace y by 1, your x value is 2. So y by 1, x value is 2. Y by 1, 2. Y by 1, just 1 and c. So c equal to 0. Go back and plug it here. xy equal to 2y to the power 6 is the answer. Make sense?
Sir, do you
Yes,
think
sir.
you can go back to the integration factor real quick? I'm just trying to write everything down.
Which one?
Just right there. That's good.
Okay.
So it basically works out the same as the other one. All right, I think I got it.
Okay. Right, guys? Then after, Margie, for you, I have solved one more example for you from your practice test, example number 8D. See, out of 6, I'm solving 4 examples. So I'm doing 70% for you, 60-70% for you. And I can expect 30% from you, right?
Yes, sir.
Yes, sir.
Just refer this example, divide by cosine x. So divide dx, your peak, tangent x, secant x, standard form, integrating factor. Integration of tangent x is, you know this thing, that is equal to ln of negative ln of cosine x. You can use u sub or you can use the formula. Plug the value of u, negative ln of cosine x. You can take this negative as an exponent, negative as an exponent. So e and ln will get cancelled out. You can cancel e and ln whenever you don't have anything except 1 here. Otherwise, you cannot cancel. And that's why we are sending this -1 or 4, what it may be, as a using logarithmic property. So we are getting cosine inverse means 1 over cosine x means secant x. This is secant x. And general solution is y into integrating factor secant x equal to right hand side is secant x. So secant square x, integration of secant square is tangent x, and we are done. We are done. Simple. If you want to stop over here, I don't mind. Or you can go for more simplification and sine and cosine. It's up to you. I don't mind. Sounds good.
Yes,
Sounds
sir.
good.
Yes, sir.
Yes, sir.
Okay. Then after, I want to start with nonlinear differential equation. You need a break of, do you need a break of 5 minutes? It's been an hour. You need a break of 5 minutes? No. Yes or no? Say something, please. Don't waste my time.
No.
No? Okay, let's continue. All of you agree with him, right, Alex?
Yes, sir.
Yes,
I'd rather
sir.
just end 5 minutes
We-
earlier if
We can
anything.
continue. What you said, Margie?
I'd rather just end 5 minutes earlier if anything.
Okay. Okay, then sounds good to me. Nonlinear differential equation. First of all, the standard formation of nonlinear, still we are working with first order, first degree, guys. Please keep in mind this thing. Standard formation of nonlinear differential equation is dy by dx plus py equal to q is linear. But if you have some factor, some function y to the power n, y square, y cube, y to the power 4, something like that, that makes your equation nonlinear. Why? Because p and q are functions of x or constant, right? Right?
Yes,
What is
sir.
the definition of linear differential equation? Dependent variable y and all its derivative are not multiplied together. Are not multiplied together. And all of them are having the power 1, degree 1. Here degrees, look at here. It's different.
Mm-hmm.
It's not 1. So that's why that makes the equation nonlinear. Nonlinear. Process, working method is like this. Whenever you are solving the nonlinear differential equation, first of all, try to convert your nonlinear differential equation in the linear differential equation form. Convert to linear differential equation by u substitution, by some substitution. And once you are in the linear form, you know how to solve it. You are in the standard form, just like our previous method, previous examples. So main thing is to convert your nonlinear form to the linear form. And once you convert it, you're good to go. Right?
Right. So there isn't any special way to solve these. It's just a matter of converting nonlinears into linears and then using what we just did. Is that correct?
That's what I said. Yes. That's what I said. Yep. Okay, guys. So how can I convert this nonlinear? These are technique. You will not find this technique in the book, please. In our book. Of course, the book is good. I told you very first day, but you will not find this technique in the book. Very frequently, I will be going out of book and give you the best technique to solve that. Some techniques, yes, which are not given sometimes in the books. I will be providing you those techniques, which will make your life way easier than referring the books. So always pay attention. This is one of them. If I want to do this thing, let me divide by this, because this term is this guy is bothering me. Let me divide by this guy. Don't divide any guy, please. But let me divide by this function. Okay. If you divide by 1 over y to the power n, so 1 over y to the power n divide dx. Here it is 1 over y to the power n equal to q. Equal to q. Equal to q. This part will give you, I don't want to touch this portion, second portion. Will give you p y to the power, here it is 1, here it is n. So can I write 1 minus n? 1 minus n, can I write like this?
Yes, sir.
Attention on my cursor, please. 1 minus n. I put the box over here. Why? Because now you are working with this box. This itself is your u sub always. Always. Whatever function you are getting after dividing your nonlinear function throughout in the middle term here, that will be your u sub always. So y to the power 1 minus n equal to u. Take the derivative. Derivative with respect to x, your independent variable, please. Don't take the derivative with respect to y or u. No, you are taking derivative with respect to x, because that's the only your independent variable right now. So n minus 1, y square derivative is 2y to the power 1 less, right? 2 minus 1, agree? Same here, 1 minus n, y to the power 1 minus n and minus 1, 1 less power. Y square derivative or y cube derivative is 3y to the power 3 minus 1 is 2. Same here. And derivative of y, chain rule, divide dx. Margi here, divide dx. Equal to derivative of u with respect to x, du dx. People are making mistake over here. They forget usually to write the derivative as a chain rule, derivative of y. And that's why everything is wrong. Try to make use of my experience. I'm explaining you everything where people are making mistake and everything. Simplify. Y to the power negative n divide dx. Just divide by this is constant. 1 by n is 1 minus n is constant. Divide by this number. Divide dx. One more thing, guys, which you will not find in the book. Once you use this one as your u sub and go for the derivative, you must get, after your simplification, you must get this one as your first term. Look at here. And that's why I put this big arrow, that your first term is, after using this u substitution, you are getting your first term. And that's what I'm getting here. See, that means this first term is now replaced by 1 over 1 minus n du dx. 1 du dx. P, this is my u equal to q. This is constant. I told you 1 minus n. Just multiply throughout. So du dx equal to 1 minus p1 minus n u q1 minus n. This is constant. Q multiplied by some constant, suppose 3x, 4x like this, 3q, 4q like this. P is constant. P multiplied by constant. Suppose 1 minus n is 4, so 4p. Okay, valid. And u. Don't you think this? And p, let me finish. P and q are functions of independent variable x. You know it right from beginning. So p and q are functions of independent variable x. 1 minus x means constant. Function of x is multiplied by, or some constant is multiplied by function of x, till it remains the function of x. This arrow. This remains the function of x. Don't you think that I have converted my nonlinear part? This is a linear differential equation. Look at here. Yes, I wrote it down. Linear. Question.
I'm just confused as to where the 1 over 1 minus n came from. When Yeah. I'm.
Here, derivative.
Oh, so you're just dividing over the side. Okay, got it.
Derivative, and
Never
then I
mind.
divide
Never
it.
mind.
Well, because you're deriving it with respect to x, that's why we're not taking the derivative of it. All right.
Yeah, I was
No,
stupid.
no derivative of n. N is a constant.
Oh, okay.
Okay. All of you are getting me. Am I right?
Yes, sir.
Right.
Yes, sir.
If you have any question, don't feel shy. Okay. So this is a linear differential equation. But my p is not simply p, simple p, it's multiplied by some constant. So my integrating factor is pdx, but not p with 1 minus n, because that's my new p now. My general solution is, don't say x or y, is we are working with this last equation. So u as a dependent variable, u integrating equal to q times, it's not q, but q into 1 minus n, integrating factor dx plus c. So same formula we are using, but not with simple p and q. Another form or general.
Like I have to create an alphabet book for French.
And finally, once you are done with this,
It's not hard.
just take.
I just forgot about it.
What is this, please?
I forgot about it, and then.
I don't want to hear some noise, please. Finally, once you are done with this integration, replace your u by y to the power 1 minus n. That was your substitution. U was not given to you. You have created u for your convenience. So your answer must not be in terms of u. It has to be in terms of x and y. So write down u equal to y to the power 1 minus n. Agree? This is the theoretical portion, you can say, or method of working, you can say, not the theoretical portion, method of working. If you keep this method of working in mind, that will help you a lot to solve the nonlinear differential equation. Make sense?
Yes, sir.
Sorry. Okay. Example. X dy dx plus y equal to x cubed y to the power 6, initial condition. If I divide by x, 1 by xy equal to x square y to the power 6. If I don't count this y to the power 6, if I don't count this circle, this is a linear differential equation, right? dy by dx plus py equal to q. But this circle is a nonlinear function. This creates the nonlinearity. This part is bothering me. Agree? So divide by this number, y to the power 6. That's what method says. Divide by y to the power 6. So y to the power negative 6 divide dx plus 1 over x, y to the power 1 divided by 6 means 1 minus 6 is negative 5 equal to x square. Getting me?
Yes, sir.
Good. Nina?
Yes, sir. I'm just trying to figure out where the x squared came from again.
X square?
Yeah. Oh, okay. No, I'm sorry.
I divided by x throughout.
I see now. Thank you.
Here 1 over x and here it is x square.
Yes, sir.
Some people, if I say divided throughout, even though some people are dividing only this term, they don't divide here. Means everything is wrong. If you divide, you have to divide throughout. Don't just divide one term. After giving these instructions multiple times, students are making this mistake. If you want to follow that mistake, that's fine, your choice. My job is to cut down your points, okay? If you don't follow me. I'm kidding you. I know you're going to follow me. Okay, good. So y to the power negative 6 dy dx plus 1 over x y to the power negative 5 equal to x square. If you remember, in that working method, I told you that this box is my u sub. Y to the power 1 minus n is this one. Agree? Agree? So this is my u sub, and after derivative, I must get my first term. That's what I told you. Agree?
Yes, sir.
So y to the power negative 5 equal to u negative 5y to the power negative 6 dy dx, because differentiating with respect to x is equal to du dx. Divide by negative 5. So you're getting this one. Means I am getting my first term. So replace first term by this one, negative 1 over 5 du dx. 1 over x as it is. Your u is nothing but y to the power negative 5. So that is your u and x square. If you multiply throughout by negative 5, you are getting the linear differential equation du dx plus pu equal to q. Or you can say p into 1 minus n, that is this function. Q into 1 minus n, that is this function. Q multiplied by some constant. Q multiplied by some constant. P multiplied by some constant. Agree? Or you can say p and q, I don't mind. Once you have linear differential equation, ball is in your court. Integrating factor, e to the power p dx, negative 1 over 5 dx. Negative 5 out, 1 over x is ln x. Logarithmic property, ln x to the power negative 5. X to the power negative 5, 1 over x to the power 5. General solution is dependent variable u times integrating factor equal to right hand side q, negative 5x square, integrating factor dxc square, and x to the power 5 means x to the power negative 3 in the numerator. Integration will give you plus 1 divided by the same number. So x to the power negative 2 divided by negative 2. Left hand side is 1 over x to the power 5. And I told you plug the value of u. U was y to the power negative 5 or 1 over y to the power 5. You can consider this as the answer, I don't mind. Or final form, not the answer, because the initial condition is there. Use the initial condition when x equal to 1, y1 equal to 1. So you are getting c equal to negative 3 by 2. Go back and plug over here to get your final answer. Any doubt in this nonlinear differential equation?
No, sir.
In this nonlinear differential equation, you want me to put this one in front of you? If you have some doubt, just try to look at this one. Try to read each and every line and try to convince yourself. I give you 2 minutes.
Sir, just to clarify, we want to get to where we have the linear form with the p and the q, and then we're usually turning our p into the u, correct? Or as like we're using that for the u sub?
Yes.
Okay. Okay.
Once you solve your linear differential equation, integrating factor, and general solution, once you solve your right hand side integral is done, then after go back to left side and plug your u, whatever you have chosen the substitution. Okay. May I proceed further?
Sir, real quick, could you clarify what you did on the same line right next to where you put linear differential equation, where the negative 1/5 kind of combines with the 1 over x? I get that you're doing the p times 1 over n, but I'm just confused as to where the
This one?
right above that.
Here?
Yeah, that line. I'm just confused as to where the negative 1/5 went.
Is negative 1/5. I multiply out by negative 5 because I have to have coefficient 1. So negative 5 is here, negative 5 is here.
Okay, so in that step, you just multiply everything on the left-hand side by 1 over n. So that cancels out the first constant. Okay, yeah, I see what you did.
I multiply throughout by negative 5. So this will get cancelled out here, negative 5, here, negative 5. Because I want dy dx plus py equal to q form. I have to have coefficient of dy dx or du dx 1 in linear case.
Okay, that makes a lot more sense. Thank you, sir.
No problem. Any other doubt, girls? Girls?
No.
Okay. Nina?
No, sir.
Okay. One more example. Let me skip this example right now. Question number 10.3. It's a reverse case of nonlinear differential equation. Look at here, dx dy form. But most likely for the nonlinear, I'm not going to ask you this thing. So please try to convince yourself. If you are not getting this thing, we can do. Just ask me. I will explain to you. It is dx dy 1 plus xy square dy dx equal to 1. So it is now not now dy dx form. It is just, linear second form dx dy, because dy dx will not give anything, because this is multiplication. See, xy multiplied by this one. If you send this one to other side, it is 1 divided by whole expression, xy 1 plus xy square. So 1 divided by that whole big expression will not give you anything in the division, in the denominator. It won't give you anything. But if you flip this dx dy, means if you keep this dy here and dx here, so dx dy equal to this one. See, xy and x multiplied by x is x square, y cube, and dx dy. So dx dy, then send this, you have to have power of x or y over y1 here. That term will appear over here, because dx dy plus px equal to q. That is a standard form. So that's why this higher power I would like to send to right side, which will make my q. And then after, if I compare with my standard form, dx dy plus py equal to q x to the power n, form 2, qx to the power n, dx dy plus p is a function of y, q is a function of y, and x to the power n, this x creates the non-linearity now, because x is my dependent variable. Always non-linearity is created by dependent variable, not the independent variable. Please keep in mind this thing, always. Because independent variable is always a function of x, p and q. Always function of p and q. Here p is a function of your independent variable y, q is a function of independent variable y. So non-linearity is created only through your dependent variable, please. And that's what our definition says, right? Dependent variable and all its derivative appear in first degree and they are not multiplied together. Right? It's dependent, not independent, please. So this is the standard formation. I mean to say, I have arranged this given function equation in this standard form, second form. And this creates a nonlinearity. So now I am in the domain of working process. So divide, this guy is bothering us. This creates the nonlinearity, divide by this part, this function. So I'm dividing by this one, dx dy, negative y as it is, x to the power negative 1 and y cube. And this rectangle box, that's your u sub. So 1 over x equal to u. So negative 1 over x squared dx dy, because now you are differentiating with respect to y. Always you are differentiating with respect to the independent variable. Always keep in mind this thing, guys. Please. So 1 over x squared dx dy, just multiplied by negative sign, and you are getting your first term as usual. So just go back, plug it over here, negative y, u, y cube. If you multiply by negative sign, here it is plus, here negative. This is a standard linear formation, linear differential equation in terms of u and y. So integrating factor y dy, y square by 2. General solution, u in integrating factor, integration y cube, actually negative of y cube, negative out, and integrating factor dy dx. And this is how you can solve this. This is your calc 2 part. You are using 2-3 times u into v rule, integration by parts, because it is y cube e to the power y square by 2. Or you can do like this, see, just write y cube and y square and y form, and y square by 2 equal to t. So whatever y square you have here, that is your 2t. And you can use just 2 times integration by parts, and you are getting the answer. Try to convince yourself. If not, let me know tomorrow morning. I just changed my mind. Tomorrow, before you take your exam we decided 10, right? Before you take your exam at 10, I would like to start our Zoom meeting at 9:45. First 15 minutes, I would like to spare with you as a review or just to solve your doubts, just to clear your doubts. Because if you are working today, I'm pretty sure you will be having some doubts.
Sir, there's a lot of doubts.
Excuse me, I'm sorry. Oh my. Lots of doubts. I'm sorry. But yeah, you have to work hard. I know you will be having some doubts. Yes. It's not Calc 1, Calc 2. I know. Let me go through one more example. I can give you one relaxation that I will not ask you this second form for nonlinear. Okay, happy? Second form of nonlinear, that's the only example you are having in your practice test, example 10.3. I will not ask you, but you need to go through this one. I may ask you the same thing in the final. So don't think that we skip this part. No. Sounds good? Oh my gosh, why I see some tense faces over here. Now you guys are not laughing. You're
There's
not,
a lot of stuff going on,
you're not
sir.
smiling now. You are getting tensed. Why? Look at Margie, see? Then, yeah, keep smiling, guys. I'm here to take care of you. Okay. Example number. Oh, when I said that I like this example, it was not this one, but actually it was this one. Example 10.2. Yeah. I like this example actually. Yeah. X divide dx plus y equal to x cube y cube. Y at 1 equal to 1. So dy by dx plus 1 over xy equal to x square by 6. Standard form if you divide by x. This y to the power 6 creates the nonlinearity. Did we see this example, or I think this is a repetition, right? Yep. Yeah, look at here. Yeah, look at here. See? Example 10.2. This thing. Yep. We did this thing. Sorry. Yep. It's just the repetition. Okay, this one. Xy square divide dx equal to y cube minus x cube. I want to first convert to the standard, this initial condition. So divide dx, let me divide by xy square throughout. So xy square, y square and y square will get cancelled out, x and x will get cancelled out. I'm going to get y by x minus x square by y square. Let me send this y by x to other side because dy by dx plus ky, y to the power 1 is there, equal to q. Let me arrange this one in the standard formation. Dy dx plus p negative 1 over x, y is separate, is equal to q is negative x square because p and q must be a function of x, and dy by dx plus py equal to q and y to the power n. This y square, y to the power negative 2, that creates the nonlinearity. Look at here. I wrote down everything for you. This is dy dx, sorry, dy dx. I wrote down everything for you. Right? Good. So this creates the nonlinearity. Divide by this number, divide by this. So 1 over y to the power negative is y square divide dx. Negative 1 over x. Y divided by y negative 2 is y cube, negative x square. Negative x square. This is my u sub as usual. So y cube equal to u. Derivative simplification must be similar to the first one. So 3y square divide dx equal to 1/3 du dx. Divide by 3. Divide by 3 is you are getting 1/3. This portion is same as the first one. Replace your first term by this right side. U x square. Multiply throughout by 3. So 3 here means you are getting linear differential equation. Linear differential equation with p equal to negative 3 by x. P equal to negative 3x square. Integrating factor p dx. Negative 3 ln x. Ln x to the power negative 3. So x to the negative 3, 1 over x cube. General solution is u times integrating factor equal to right hand side negative 3x square integrating factor plus c. Cancel x square and x square. 3 ln x. Negative 3 out. Integration of 1 over x is ln x. U is your, what was my u? Y cube. So y cube by x cube, negative 3 ln x plus c. Multiply throughout by x cube. So negative 3x cube and x cube. So this is my general solution. Use the initial condition y at 1 equal to 2. Y at 1 equal to 2. And you are getting c equal to 8. Plug that value over here, c equal to 8. And you are done. Simple. Simple.
Simple enough, sir.
Yeah, so I think the hardest part's just getting it into the linear form and just making sure that all your I's are dotted and T's are crossed before you work through the rest of it.
Yep. So this is linear differential equation. Now look at over here, guys. Just try to keep this equation in mind. This is linear. I solved this example by linear, non-linear differential equation. Am I right? What is the power of x here?
1,
Power of y?
2,
Product is a product. So total power is?
3,
Power is? Say
3.
3.
That's the rule.
What is the power of here? Power of y here?
3,
Then minus sign. So separate. What is the power of x here?
3.
So if I divide by xy square, that's what I did here. If I divide by xy square, just not like this, but like this. Look at here. Xy square dy dx equal to y cube minus x cube. This implies that dy dx equal to y cube minus x cube over xy square. Like this. Look at the last line.
Okay.
Agree? What
Yes,
is
sir.
power of y in the numerator? 3. Then minus sign, so separate. Power of x in numerator? 3. Separate.
Wait,
Divided.
can you move the paper over a little? Okay.
First one is just the equation.
Mhm.
So in the second part, division is xy square and product power. Whenever you have product, just add the power. So 2 plus 1 is 3. Don't you think power of numerator and power of denominator are same? Power in numerator and power in denominator is same. Don't you think like that? Power in numerator is 3. Agree?
Right.
Power in denominator is 3. Agree?
Yes, sir.
And they are same. Agree?
Yes, sir.
Right.
Agree?
Agree.
Yes, sir.
Girls,
Yes, sir.
Yeah.
right? Whenever power of numerator and power of denominators are same, that differential equation is called a homogeneous differential equation for first order, first degree, not for higher order. First order, first degree homogeneous differential equation whenever power of numerator and power of denominator are same. Dy dx equal to same power. So this is, of course, I solved this example by nonlinear differential equation, but the same equation can also be solved as a homogeneous differential equation too. Right? Are you getting me or not?
Right.
Yes.
Right? So homogeneous differential equation. So my next part is homogeneous differential equation. There is no particular method. Of course, particular method is there, but I would like to give you that method along with the example. And let me take the example, question number 9, A part from your practice test. Again, I'm helping you guys. Homogeneous differential equation. Whenever power of numerators and power of denominators are same, it's a different example. X square and 1 and 1, 2 and 2. Agree? But that example can also be solved by the same thing, same way. And that's why I told you I like that example. You know, in the beginning of this class, I told you that one differential equation can be solved by several ways. Here, this is the example. This example can be solved by 2 different ways. The previous example, I would say. Where is it? This one. No. This one. 2 ways, because powers are same, numerator, denominator. So you can use the homogeneous technique over here and make sure you must get the same answer. Agree? Make sure you must
Yes, sir.
the same answer. Okay. So what is the method of solving? Method of solving is method of solution. Take y equal to vx always. Take y equal to vx. So naturally y equal to vx means v equal to y by x. Agree? Keep this box aside. Keep this box aside. We are not using this one right now. We will be using this one at the end of the example. Just keep this one aside. All of you are getting me or not? I know you guys are tired, but that was your choice not to take the break, right? Now,
Sure.
Yes, sir.
sorry. Okay, so y equal to vx, differentiating with respect to x. This one divide dx, agree? Differentiating with respect to x, so x as it is, derivative of v with respect to x, so dv by dx and x as it is. And v as it is, and derivative of x, dx by dx is just 1. So dy by dx equal to v plus x times dv by dx. Agree?
Yes, sir.
All of you are agreeing? All of you agree?
Yes, sir.
Girls?
Yes, sir.
Girls?
Yeah, I got it.
Good. So this is your dy dx. Go and plug this v plus x dv dx over here in your equation. See, that's why I put this big arrow here. Right? So it is now v plus x dv dx. That's this one. Equal to right hand side x square plus y square is v square x square. Y is vx. So it is v square x square divided by 2x as it is. Y is vx. So everything is now in terms of v and x. Y is not there. Agree?
Yes, sir.
Yes, sir.
Is in terms of v and x. Y is not there. X square common 1 plus v square. Again x square out and 2v. X square and x square will get cancelled out and you are getting 1 plus v square over 2v. Agree? All of you agree with me or not?
Yes, sir.
Argi?
Yeah, I got you.
Nina?
Yes, sir.
After doing this thing, this is just a function of v. What I'm doing, send my v, whatever v I have on left side, just send this to other side. That means again, I will be having everything, every v's, all v's here on right side. 1 plus v square over 2v minus v. Agree? And here it is x dv by dx is only left out things. If I take LCM is 2v, means divide and multiplied by 2v here. So you're going to get 1 plus v square minus 2v square divided by 2v. Simplify 1 minus v square by 2v. I am getting narrower and narrower equation. See, x dv by dx equal to 1 minus v square over 2v. 1 minus v square over 2v. I want to separate this thing now. This dv is here. I want to send all my v's on my left and all my x over dx on my right. So I can do like this, where all my, where I was, yes, 2v over 1 minus v square, 2v over 1 minus v square and dv equal to this x and dx, 1 over x dx plus c. Agree?
Yes, sir.
Yes, sir.
Short. Again, you will not get this sentence in the book. In short, all homogeneous differential equations are converted in the form of separable variable after your y equal to vx substitution. Look at here, this is separable variable. See, separable variable. Am I right? This is not just one, all. My previous example, which I solved by nonlinear method, will be following the same method and it will be converted again to separable variable like this. Makes sense? Makes sense?
Yes, sir.
Makes sense.
Yes, sir.
Okay. How can I get the integration of this one? 1 minus v square. Derivative is negative 2v. I don't have negative. So let me divide and multiply by negative sign. Or you can take 1 minus v square equal to u. Your choice. It's just calc 2 now. That's not my part. Calc 2. Again, I'm starting techniques of integration tomorrow. Tuesday, my students are taking exam. So you will be free on Tuesday. You are not supposed to join my Calc 2 group on Tuesday because they are taking exam. Monday is Memorial Day, you are good. Only thing is you need to spend 3 to 4 days. If you think that you are not good at Calc 2, you are the best judge of yourself. So just stand in front of the mirror, ask yourself, yeah, mirror never says wrong. Mirror always says what you are, always. If you have some black spot here, your mirror will say, yes, black spot is there. It won't say wrong. Mirror doesn't lie. So just keep yourself in front of mirror. I mean to say that just ask yourself. Ask yourself, hey, Dimple, are you good at Calc 2? You know all different kind of methods of solving integrals. I know some. Why some? What are the things I don't know? Let me try to figure it out. Let me read the things. Ask yourself. And be honest to yourself. Because you can cheat the world, you cannot cheat yourself. Your inner voice always will let you know the right thing. If you know, I know everything, but inside you know this thing that you don't know everything. So don't cheat you can't cheat yourself. You can cheat the world. Yeah, I agree. You cannot cheat yourself. Be honest. That will give the right answer. And if you think that you are not good at Calc 2, join me tomorrow morning. And Wednesday, Thursday, and Friday. Just 4 days I want. Maybe 5 days, but not more than 5 days. And I am providing you this opportunity. If you think that, no, you don't want this help, your choice, just forget. Okay, so here 1 minus v square equal to u, negative 2 v dv derivative, plug the values, and you are getting negative 1 over u equal to 1 over x dx. Now one more thing, one more technique you will not get in the book. Listen to me. Yeah, I know I'm teaching you Calc 2, that's not my part, but no, I can't stop myself. Whenever Nina says something, she knows this thing because she took Calc 1 with me.
Yes, sir.
Usually I don't teach Calc 1, I don't like to teach. But last semester, yeah, somehow, no, not last semester, right? It was last fall, right?
Yes, sir, fall.
Last fall, yeah. I had to teach Calc 1, but that's fine, I don't want to discuss that thing. Anyway, so ln u equal to, whenever you have all your expressions in ln, see integration of 1 over u is ln, integration of 1 over x is ln x, always consider your c as ln c blindly. If you are not considering over here ln c, and if somebody says, no, I want to stay with just c, okay, fine, you are increasing 4 or 5 more steps. Waste your time, I don't mind. Otherwise, if all your expressions in the given equation, if every expression, everyone means without leaving a single one, if every expression is in the ln form, see integration ln, just say your constant also ln. That is just without loss of generality. You're not losing anything. Again, ln property, u to the power negative 1. This negative 1, take this one as an exponent, ln x, ln c. But what was my u? My u was, look at here, u was 1 minus v square. Plug the value, 1 minus v square and inverse. That is 1 over 1 minus v square, ln x and c. This is 1 minus v square and minus ln of a minus ln of b, that is equal to ln of a divided by b. Another property of logarithmic function. Ln of a divided by b. That's over here. Ln of a divided by b. So you are going to get this one. And ln c outside. This ln and ln will get cancelled out, see? And I'm getting c equal to 1 over 1 minus. Now v, what was my v? I told you I'm going to use my v at the bottom of the
y over x.
Y over x. So y over x, because v was not given to you in the example. You created that substitution for your convenience. So whatever you created, just remove your creation. Calc 2 doesn't want your creation. DFQ doesn't want your creation. DFQ just want the answer in a straightforward way, right? Or right way. So y square by x square and x and c. So x over y square minus x, x will get cancelled off, that is c. That's the answer. And that's how homogeneous differential equation works. Margi, I solved one more example, question number 10-4. And question number 9-2, I wrote it down. See, can you see this is exactly same 9-2 nonlinear homogeneous equation?
Yeah.
Right? And same example I have solved using the homogeneous. You will not find this type of things in most of the books. Books are, or different authors, they are taking different examples. But the best way of teaching is just to take one example and apply different methods on that example so that student can come to know that same example can be solved by several ways. Getting me? Getting me?
Yeah.
Sir.
Right? So I applied the same method, and I'm getting the same solution, whatever I got in by my non-linear method. Right? Same thing, power 2 and 2, but square root is there, means power 1 and 1, power 1, power 1. So same power, homogeneous, same technique. And let's stop here. Exact differential equation, I don't want to start this one. Exact will be the part of your second test. Your test syllabus, your syllabus for the first test is over here, Now, let's talk. Do you think that these things are too much for you? Be honest to yourself.
Sir, I feel like it's a lot, but I'll be able to figure it out by tomorrow.
Other guys, so who said this thing? Alex?
No, for me, I just think I need to refine it a little better. Like, I'm starting to like understand it, especially yesterday when I was working on it. So I just got to refine it.
Means what you mean? I don't understand you. Will you be good?
I should be good for tomorrow. Yeah.
We just need practice.
Yeah, that's what I'm gonna do.
Yeah, you need to practice. I agree. This course is full of practice. I mean to say, I told you very first day, if I'm teaching here 2 hours, you have to practice the same examples at least for 3 hours. At least 3 hours, actually 4 hours. And you should practice like this. I don't know what's your method of learning, but whatever examples I'm teaching over here, you have to write it down. Same example, same, without changing anything. At first level, you will be stuck at lots of points. Okay, look at the solution. Again, write it down. Look at the solution when you're stuck. Again, write it down. Then solve the same example without looking at the material. Don't look at anything. Just write the same example 3rd time. Then, once you are confident, then attempt your unsolved practice test example. That is the best way of learning. But what people are doing, what students are doing, they just try to finish the homework quickly. And that's why they attempt those examples without solving the same thing in the class. That's not the way of learning. You can't learn anything like that. Nope.
Sir, since
so, one minute.
Differential equations aren't going to be on.
I don't know who is there.
Yeah.
Keep your video open and ask me. I'm not getting you, please. Who is there? Will? Oh my gosh. Who is there?
Sir, can you not hear me?
I can hear you, but I want to see you.
Yes, sir.
Who is there? Will?
It's Will.
Oh, Will. Okay, go ahead.
I'm on my phone, remember?
Yes,
Yeah.
but I can't hear you clearly.
Yeah, since
go ahead.
Since exact differential equations.
Mm-hmm.
Can you hear me now?
Yes.
Okay. Since the exact differential equations aren't going to be on the first test, do we not have to do that section within the practice test?
No.
Okay, so don't do section 11?
Nope.
Okay, sounds good.
I have not taught you that portion so far. How can I ask you for the homework? No. Okay. Any other question? So all you guys think that you will be good for the exam tomorrow? Be honest.
Yes, sir.
Yes, sir.
I don't know about good, but I'll survive.
I feel that way too.
Oh, you feel like that too, Nick?
Me.
No, that wasn't me, sir.
I feel like that too.
Oh my gosh, you too, Ilyas?
I was the one who said, hopefully, like will survive. So
Queen Heart? Queen.
Yeah, I said that. Yes, sir.
I'm not getting you. Say again.
I agreed with Tyson.
You agreed with whom? No, your voice is getting echo. Echo voice I'm getting over here. Hello?
Can you hear me?
Yes.
Okay, I just agreed with Tyson.
No, I can't hear you. It's getting echoed. No.
Sir, he says he agrees with Tyson.
He agrees with Tyson. Means what? Tyson, what did you say?
I was saying that hopefully we'll survive. Sir.
Hopefully you will. Okay, then Margie, what do you think?
I think it'll be okay. I don't think it'll be like bad or good, just like okay.
Sir, just be gentle.
No, why I'm asking you guys, if you think that, see, after today's class, if you think that you need some more time to prepare yourself, and if you want to use it, use the weekend, long weekend for this one, of course, still I'm not in favor of that. But if you want that thing, I don't mind. I just want you to perform well in the exam. So that's why, because yesterday we decided that you guys are going to go for the exam on tomorrow. But if you change your mind after today's class, I will support you. I don't mind. It's up to you. Just discuss in between and let me know. I don't want to involve in your discussion. Just discuss in between and let me know, okay? I am just side to your discussion. Just discussing. I give you 2-3 minutes. Talk to each other and let me know. I sent this page to Nina. She will send it to you.
Yes, sir, I got it.
Yep.
Just one page?
Yeah, one page, yeah.
Okay.
Sir, do you think that we could all go through and do our own respective studying and everything tonight and then get back to you with whether or not we'd feel confident tomorrow morning? Because I feel like a lot can change in an afternoon.
So that means you want to give me your decision tomorrow morning? No.
What about at night, like at 8 p.m. tonight, after we can study, maybe review?
Okay, fine.
Kind of stressful to not know whether we'll have
Nina.
Yes, sir.
Do one thing. Okay,
Yes,
so you guys are going to meet after this meeting, right? And try to discuss the things. Am I right? Am I right?
Yes, sir.
Yeah. So Nina, can you do one favor for me or somebody else? Maybe who? Somebody else means who? Maybe Harris or Elias Tyson or Nick. Any one of you set up the Zoom meeting. Don't involve me, please. Just set up the Zoom meeting amongst yourself. Decide this thing. And Nina, send the message to me on my cell phone about your group decision. Sounds good?
Yes, sir.
Okay, I don't mind. That's fine. Just send the message to me before 8 p.m.
Yes, sir.
Okay, guys, thank you so much. I just want you to perform everything. See what I'm thinking. If you decide to go for the exam tomorrow, I'm ready. If you decide to go for the exam on Tuesday, I will spend some time with you just for a review tomorrow. And immediately after that, I have to start the another differential equation. That is another method, exact differential equation. Of course, again, exact will not be the part of your exam first test, whether you go for tomorrow or Tuesday. Exact will be the part of your second exam, okay? Just to make you happy.
All right.
Okay, so just decide amongst yourself and then after let me know before 8 a.m. Not all you guys, just Nina. Just send the message to me, okay?
Yes, sir.
Thank you guys.
Yes, sir.
And have a safe, not weekend, right? Safe day, healthy day. Be happy, stay happy. I'll see you tomorrow. Thank you, guys. Any case, right?
All
Tomorrow.
Yes,
Okay.
sir.
Thank you.
Yes,
Bye.
sir.
Have a good day, sir.
Thank you, sir.
All right.
Bye.
Dr. Dimple.